Hello everyone, this is Dr. Carlos Galera Zarco. Welcome to this new session in your module Big Data and Business Analytics. Basically today we are going to run this notebook and we are going to cover two main aspects. The first one is going to be the supervised prediction using regression, and the second part would be the supervised classification models. So basically, we are going to continue exploring the scikit library and showing you how to implement some machine learning algorithms. Okay, last week we were talking about the scikit learn machine learning library. Uh, I suppose that you are now familiar with this website. And basically, in the last notebook, we were covering clustering, and today we are going to check regression and classification. Well, keep in mind this flow chart because, as I said, it's very interesting in order that you understand, depending on what you want to do and the data sets that you have, you can define easily the path that you can follow. Okay, for this first part of the session, we are going to continue using this data from the Building Data Genome project. That it was the data set that we were using last week. I already uploaded the three data sets that we are going to use now. For the first part, we will be using weather to an unit class Chiara, and for the second, this data set. But I would recommend you to upload all of them now. Let's load the relevant libraries that we will need, basically pandas, matplotlib, and then the packages needed from scikit-learn. And what we are going to do basically here is to predict the energy consumption. Last week we were doing some analysis about energy consumption, and today what we want to do is prediction. Okay, so based on actual data of energy consumption, we are going to predict uh, the consumption for a determined period of time. This is useful, for example, when in a building we are planning to install something to reduce the energy consumption. I mean, we are going to implement an energy conservation measure, so it would be useful to predict the energy consumptions without adopting an energy conservation measure and after adopting that. Okay, this could be an application. But what we are going to do now is basically to predict from a certain point what is going to happen regarding the energy consumption without adopting anything new. You can find here more information about the use of machine learning for energy consumption, etc. Well, let's load the data set. As I said, is this one, unit class Chiara, and it's the same, and the data is structured same way that we had last week. So we have the timestamp here and the energy consumption in that column. Okay, we are giving the index column for timestamp, and here you can see how the data look like. Basically, in that axis we have the energy consumption, and here we have time, that if you remember we have 1 year of energy consumption. And now what we are going to import are a data set for weather conditions. Weather conditions for this particular scenario, which is unit class Chiara. Okay, so here you have the data set. Basically, the index is again the timestamps, and now we have here several columns gathering information about weather. As you can see here, there are some empty values that we should fill, and also we should remove the outliers, okay? So by using this function, resample by hours, we are going to order our data by entire hours, okay? 0, 1, 2 for the same day. You have there the data. And here we are going to remove some outliers. And here we are going to fill the gaps. So now this table is tidy and clean, and we are going to select the temperature column. Okay, we are going to use this variable from the weather data set. So here you have now the temperature for each hour. And this is basically how the temperature behave. Well, now we are going to use supervised learning. Okay, if you remember, when we talk about supervised learning, we are going to use a data set to train the model, and then the model will predict other results. So with that practice, we are going to use the data from these 3 months, it would be April, May, and June, to test the model in order that we can predict the energy consumption for month number 7, means for July. So what we are going to do here is to extract the training data, that will be the data corresponding to these 3 months. And we can do that by using specific functions from datetime library. And here, this is the data corresponding to the month 7, which is the month in which we are going to try to predict the energy consumption. So here you have the info. We have 2,184 entries for training, and for test, obviously, is less. It should be like 3 times less. But again, as we did last week, we need to change the temporal variables, time, day, and day of week, into categories that the model can use more effectively. So we need to get dummy variables. In machine learning, a feature is a training data transformation that the model uses to find behavior for predictions. Okay, so different features will train the model. In that case, we are going to use only 3 features. That will be hour, day of the week, and temperature. So here we are defining the train features. We are getting dummies from the hour of the day, from 0 to 23. It means 24 hours. The day of the week, from 0 to 6, 7 days. And here you have the temperature. Okay, we include the temperature here. So it means that for the first hour of the first day in the month 4, which is a Wednesday, the temperature was minus 5.5. Okay. Well, after following the process in the cheat sheet, we decided to use this model, key neighbor regressor model. Okay. Here we're creating the dataset for test features, and we will use the model. And here we are going to use the model to predict. And now we can create a framework to predict the actual value versus the predicted value. Okay. And here you can observe the actual values and predicted values. And we can plot it in order to check how good the model fit the variations. This is only for the month of July, but if we want to see the integration of our prediction into the whole period, here you have the 3 months that we use it to train the model, and the prediction against the actual energy consumptions. Well, we can test quantitatively how good the model performs. So we can use mathematics method to check this. One typical method is the mean absolute percentage error. So you can check here the mathematical formula that we are following, and we can code this formula in order to calculate the mean absolute percentage error. In that case is 6.9. This means that our error rate is close to 7%. Obviously, as you learn more about machine learning, you can understand better how to optimize your error rates. And actually, the minimization of the errors in machine learning algorithms is one of the key objectives. But also it's true that lower error is often a trade-off with model complexity, runtime, and cost.